Good morning, students. Today we have come to the topic on permutations and combinations. This topic is not simple. Now, if given a difficult problem, my advice to you is you should break it down into different scenarios and you work towards the answer. Without further ado, let's look at question number 1. Now, in question number 1, there are 6 boys and 3 girls. Part 1. If there are no restrictions, how many ways can they be seated in a row? This one is pretty simple. Now, no restrictions. Altogether, there are 9 people. Alright, so it's 9 factorial. Now, you can look at it, how we arrive at 9 factorial. 1, 2, 3, 4, 5, 6, 7, 8, 9. The first person will have 9 choices, followed by 8, 7, 6, 5, 4, 3, 2, 1, so on and so forth. And then you multiply together, so it gives you the answer of 9 factorial. Now, part 2. 3 girls are to sit together. Now, what we can do is we consider these 3 girls as one entity. So you have 3 girls here as one entity. Right? So this is a 3 girl. And then followed by 6 boys. So altogether you got how many entity? You have 7 entity. Now, how many ways can you arrange this 7 item? It will be 7 factorial. Now, but these 3 girls can also be permutated because these 3 girls are distinct, they are not identical. So you must times 3 factorial. That will be your answer to part 2. Now, in part 3, the girls are to be separated. One particular boy must sit on the extreme right. Now, let me draw. 3 girls are to be separated. Maybe what we can do is we take out the girls first. Alright, so you have 6 boys. 1, 2, 3, 4, 5, 6. Now, one particular boy must sit must be seated on the extreme right. Let's say the boy B1 is to be seated on the extreme right. Now, how many boys are left? You have 1, 2, 3, 4, and 5. Now, so the remaining boys will have, there are 5 factorial for them to sit in these 5 empty chairs. Now, after that, you try to fill in the chairs. How many ways can the chairs be slotted? They must be separated. So you have 1, 2, 3, 4, 5, 6. You cannot put any chairs here. Alright, because this is the boy B1 is supposed to be on the extreme right. So you have 1, 2, 3, 4, 5, 6. So the first chair will have 6 choices, followed by 5 and 4. Now, the chairs are similar. So you need to divide this by 3 factorial. Okay? This is for part 3 of the question. Let's move on to part 4. In part 4, the 9 of them are to be seated at the table of 12. So there are 12 chairs with identical seats, with 12 identical seats. Now imagine this table is placed in the Sahara Desert. There's nothing there except sand. All right. If I blindfold you, all right, you imagine you are one of the boys. All right, I blindfold you. You have to be seated first. I blindfold you. All right. Then we walk 2 or 3 rounds the table. Okay? You didn't see the surrounding because you are blindfolded. And I remove the blindfold. I then place you at any seat. Now to you there's no difference because everywhere is the same. It's just sand. Alright, so the first person who sits doesn't matter where he's sitting because this is a round table. It's symmetrical. Okay. Now you have 9 people, you have 12 chairs. So the first one doesn't matter. So he can sit anywhere. So the first one is seated. Then he is left with 8 remaining. Now, then the next one, it does matter where he's seated because he can take reference to the first person, whether it's 2 seats away from him on the right or 2 seats away from him on the left or directly opposite. So he has some reference point compared to the first one. So 1 seat is taken. So the next person will have 11 choices, followed by 10, 9, 8, 7, 6. So altogether there are 8 of them. I mean you take away the first one, so you got 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. Alright? 1, 2, 3, 4, 5, 6, 7, 8. Alright, that should be your answer for part 4. For part 5, the seats are numbered and the girls are to be seated together. The empty seats are to be separated from each other. Now, first of all, the seats are numbered. So the seats are not similar as like in part 4. Now, how do we approach for some, like, where it's a circular table where the seats are not similar? So I would recommend, for me, I would do it as, I will approach the problem in 2 parts. One, I assume that the chairs are similar. All right. Then later, what happened if it's not similar? So I do some modification, and then that's how I approach. I will show it to you using this example. Now let's say the 3 girls are to be seated together. How do you ensure the 3 girls sit together? Now we can do it like in part 2. We consider the 3 girls as a single identity. And then you place them in this circle with them seated together. Now the next is empty seats are separated from each other. How do we ensure that? We can, after placing the girls, we can place in the 6 boys. After that, we can slot in the chairs. By doing so, we can ensure that the chairs, the empty chairs are separated from each other. Let's start off with the girls first. So you have 3 girls. So you're considering them as one entity. So let's place the 3 girls here. So how many choices does the 3 girls have? There's only one choice. because we are assuming the chairs are similar or are identical. So it doesn't matter where they are seated. It's the same because they got no reference point. But the three girls are different. So among them, you can permutate. So times 3 factorial. Next, we remove the empty chairs. Maybe I just take away 3 of the chairs and we put in the boys. So now, let me place the boys. 1, 2, 3, 4, 5, 6. B, 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 B. Now, how many choice does the first boy have? 6 followed by 5. The next one is 5 followed by 4 followed by 3 followed by 2 followed by 1. Or you can put it as how many permutations are there, all right, once you put in the boys. There are 6 factorial. So you multiply by 6 factorial. Now we put in the chairs. Where can we slot in the chairs? We can slot in the chairs here, 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 or here. So you find that the first chair got 1, 2, 3, 4, 5, 6, 7. 7 choices, followed by 6, followed by 5. Now, not forgetting that the chairs are similar because we assume the chairs are identical first. So you must divide by 3 factorial. Now there are 12 different chairs. So we need to multiply this by 12. That is your final answer to this question. Now you may be asking, why do we multiply them by this answer by 12? Let me show you why we must multiply by 12 the number of different chairs via an example. Let's say we have a table with 4 different chairs, on 4 numbered chairs. Alright, so you have 1, 2, 3, and 4. And we are supposed to place 4 boys onto this round table. So let's name the 4 boys as in A, B, C, and D. Now, if the chairs are similar, how many ways can we put these 4 boys? You will have 3 factorial ways. So let's imagine we put A here, and we put B here, and we put C here, and we put D here. All right, A, B, C, D. Now, if the chairs are similar, you will find that if I rotate, everybody move to the right by 1 chair. All right, if the chairs are similar, A, then I have maybe B, then I have C, and then I have D. I rotate them. You find that they are the same. We count them as 1 because this is a round table. All right, imagine the Sahara Desert. Earlier on, C sits opposite A. In this case, you move everybody by 1 seat to the right. You'll find that the orientation is exactly the same. So it's considered as 1. But if the chairs are numbered, then they are considered different. So each of these combinations, because there are 4 chairs, 4 different chairs. So each combination you will need to multiply by 4. So likewise, in this example, you need to multiply by 12, the number of different chairs. For that, we have come to the end of this question. I'll be doing some more questions on permutation and combination. Hope you have learned something and continue watching our video. Thank you and have a nice day.